So this is just continuation of the last video of mesh analysis, except today we're going to be adding dependent sources in the first example, and maybe we'll add some current sources, which is SuperMesh. Instead of SuperNode, we'll be dealing with SuperMesh. So let's take this circuit. We have a voltage source of 5 volts. We have a dependent voltage source of 2Vx. Then we have a 4 ohm resistor here. We have another 4 ohm on the bottom. And let's call this voltage Vx. We have 2 ohm. Another voltage source of 3 volts. And let's say the question was to find I sub 1. And we'll define I sub 1 this current. And again, I'm going to use mesh analysis. Just like we said before, we're going to assign current. And since I sub 1 is defined going this way, so this is my I sub 1. This is the same as this. And I'll call this I sub 2. Let's do a mesh KVL right here, this mesh. So KVL in mesh number 1 or loop 1. Let's begin with this, minus to plus. I'm going to use a minus. Again, you can use a plus if you want to, and plus to minus to be negative is up to you. Minus to plus, that's a minus 2Vx. Plus to minus, that's a plus Vx. And keep going. Since I define I sub 2 going this way, let me find out what is this voltage plus to minus. Using Ohm's law, that voltage is going to be what? 4 times what? I sub 2. And if I clean that, I'll have what? Negative Vx plus 4 times I sub 2 is equal to 5. Let's look at KVL for this node.
4 ohm,
For what?
where Vx is.
I'm going to write that in a minute. Yes. Because you're going to have 2 equations by 3 unknowns. You'll see. So I have to replace Vx by something else. So if you look at this mesh here, this loop here, KVL for that, plus to minus, that's plus 3, minus Vx, plus, since I'm traveling this way, I'm going to mark this plus to minus, and the voltage there will be what? 2 times I sub 1. So again, that's negative Vx plus 2 I sub 1 is equal to negative 3. I got a problem here. I have 2 equations by how many unknowns? 3. I can't do it. I got to solve or come up with a third equation Well, let's look at Vx. Vx is labeled plus on the top, minus on the bottom. So if I look at Vx, Ohm's law says V equals I times R. So 4 is R times I. Well, what is the current coming down? Because it's labeled plus to minus, so I need to know the current traveling down. What is the current traveling down in that one?
I2 minus I1.
Yes, it's I sub 2 minus I sub 1. So now if I take that and replace Vx with that, I have two equations by how many unknowns? 2. And I'm done. So a negative 4 times I sub 2 minus I sub 1 plus 4I sub 2 is equal to 5. And if you do the math here, that's 4I sub 1 negative 4I sub 2 plus 4I sub 2, which is what, 0? So if my math is correct, that's 1.25. Let's look at I sub 1. Let's look at that equation. Replace negative 4 times I sub 2 minus I sub 1.
Would you replace the I sub 1 with 1.25?
Yes, I'm going to do that. I'm just going to clean it first and I'll replace it. Yep. Actually, I don't need to because the question was what? Find I sub 1, right?
Yeah.
Done. I'll do I sub 2 anyway. The question was find I sub 1. So right here I'm done, but I'll go through it. So let's see, that's 4I sub 1 plus 2, that's 6I sub 1 minus 4I sub 2 equals negative 3. Now I'll replace I sub 1 with 1.25. So 6 times 1.25, do that in your head, that's 6, what's that, 7.5? I think. Bring this one here, 10.5. I sub 2 will be positive 10.5 divided by 4. Better use my calculator, don't trust me. .5 divided by 4. It is 2.625. As I said, I don't need that, but if I do need it, we have it. So that's dependent sources or not, wouldn't change the procedure. Everything stays the same. What we like about mesh analysis, when you see a lot of current sources, you go, oh boy, this is perfect. So let me see one, if I can take current sources in it. Different example now. I'll do a couple of them here. Leave a space on the top, a little bit because we have to go up with it. That's 1 ohm. That's 7 amp. Two ohm. Three ohm. 1, 2.
Is it similar to the one we did yesterday?
Well, we have a current source here.
Yesterday, but last time.
We have a current source. We didn't do mesh analysis with current sources yet. So this is the first time we're putting a current source there. Maybe we do it with nodal analysis, but not with mesh. I don't remember what we did last time, but not, this is the first time, because that's a super mesh. As I said, with mesh analysis, we love to see current sources. Again, we assign current any direction that you want. I always assign them in this direction, but you can assign them any way you want to. That current source here. See, now I have a problem. I can't use mesh analysis right here in this loop. I can't do it. Sum of the voltages in a closed loop is 0. Well, what is the voltage right here across that current source? None of us knows that. Can you see that? I don't know it. I can't use this loop either. Sum of the voltage in a closed loop is 0. What's the voltage right there? That's gone. I don't know what that is. I just know that's the current source. So I only have this one. Or the outside. Or I can travel this way. See it? That's a closed loop. Can everyone see that? Follow my finger? I can do the outside. That's a closed loop. I can do this, but that current source creates a problem for me. But the nice thing about that current source is it says I have 7 amp pointing down. That's your first equation. That 7 amp is equal. What is the current down in terms of I sub 1, I sub 3?
I sub 1 minus.
That's it. That's your first equation. That's equation number 1. Since you have 3 unknowns, you know you're going to have 3 equations. So that's my first equation. I sub 1 plus 0 I sub 2. There is no I sub 2. Minus I sub 3 is equal to 7.
Wait, how do you know it's equal to 7? Where did you get that? Just because.
That current source. It says the current coming down through this node, this branch, or this leg is 7. And that current, I sub 1 is pushing down, I sub 3 is going up.
How do you know that's all the current that's coming down from the.
That has to be all of it. That's a current source, independent current source. That's it. There's no other current. I'm defining I sub 1 as the current, like if there's nothing else, I sub 1 is that current. If there's nothing else, I sub 2 is the current going through that. If nothing is connected, I sub 3 is that current. So when you put them together, this one actually 1 coming down, 3 going up. Now let's take this outside loop, because I need 3 equations. Let me start with the outside loop. KVL outside. Negative 7. I'm traveling this way. Negative 7. Keep going. Come down this way. I'm traveling down. It's going to mark that what? Plus to minus what? 2I sub 2. Keep traveling, keep walking. I'm going down, plus to minus. What? Excuse me. Thank you. Keep traveling. Back, back. That's it, isn't it? So if you clean that equation, you will have what? 0 I sub 1. I'm making them that way because I'm going to use my calculator right now so I can plug in the coefficient for them. Plus 2 I sub 2 plus I sub 3 has to equal to 7. That's equation number 2. And now I got to come up with the third equation.
Don't you just do that small closed loop?
You want to use a small one? That's fine. I want to get some highlighters. I have color options now. So the second one here, just in case you're following this, or you go home, you forget, that's what I did, the second one. Can you see the yellow on the screen? I did it that way. That's where the yellow one was, the outside one. That's this one. Now we need one more equation. There are three unknowns. You want to use the little one? You can. Or you want to use this one? You can. It's up to you. So you choose which one?
Let's do I sub 2.
This one? So you want to do this one for the next one. Can you see the pink? I'm traveling this way. So let's do that. KVL, top left, top right. That's the purple. I'll make it purple color too here, so you'll know that goes with it. Begin with one like this one. Let's traveling this way, so I'm marking them plus to minus as I'm going. I'm traveling clockwise with them. I'm going this way. So the first voltage right here is going to be what? 2 times what's the current through that? I sub 2. Plus 3 times what is the current going from right to left?
I sub 2 minus I sub 3.
I sub 2 minus I sub 3, yes. Continue going plus 1 times the current going up. I labeled it plus to minus, so I'm looking for the current up. What's the current up? I sub 2 minus I sub 1. And now if I can combine like terms, I have my third equation. So I have negative I sub 1. Let's look at I sub 2. There's 1, 2, 3, that's 6 of them, is it? I sub 3, we have what? Negative 3 I sub 3 equals 0. My 3 equations by 3 unknowns. And you can use any method to solve them. Thank goodness for my calculator here. Where's home? Let me get out of this. Second quit. I'm going to go to my calculator and type this. I have that app, 3 equations by 3 unknowns. Nope. New one, 3 by 3. And now I just got to type the numbers in it. The numbers are 1, 0, negative 1, 1, 0, negative 1, and the answer is 7. The next one, 0, 2, 1, the answer is 7. And the last one, negative 1, 6, negative 3, and 0. And now I'll say solve it. And here is my answers. I sub 1 is 9. I sub 2 is 2.5, 5 over 2. And I sub 3 is equal to 2 amps. So once you get the 3 equations by 3 unknowns, you can solve them any way you want to. I have some people online asking me, can I use determinant? Can I use Gauss-Jordan method? Can I use solving 3 equations by 3 unknowns by substitution? Elimination method? Any method you want. Can I use Mathematica, calculator? You know, we cover all that stuff in math, the different techniques. This is not a math class, so any method you want to use to solve them is fine. As long as you can solve them for this class. Now, we have this, again, a super mesh here, because if you want to take this loop, if you opted to go, I don't have a blue, I used to have a blue highlighter. I could have done this actually as one loop. Maybe I'll do that next time. Something like this, just to change it. So we call that SuperMesh. Let me try another one. Another circuit. What I'm going to do here actually is about just to change that source to a dependent source. Then I go, oh, that's boring. We just did that one. Let me find something better actually. Maybe I'll look in the back of the book, see if I can find something crazy. Okay. I found color them here. I'm looking at the book and I go, oh, this is cool. Here we go. So I'm looking for a dependent source. I could do this, I could do this, I could do this, I could do that. Which one? Any preference?
Bottom right.
Which one? Top right?
Bottom right.
This one?
Yeah.
Okay. So you want to do that one. Here we go. Start with the top. That's a new example again. That's a 10. I make my graph a little bit bigger there because I know I got to label a lot of stuff inside it, so I want to make sure. Plus to minus 4. Minus to plus, minus on the top, plus on the bottom, 3i sub O. Independent current source of 5. Five here. 4. Another current source here. That's a good current source. We like that one. 6, because we just took one equation out.
And we've taken 2 out.
Well, this one didn't take it completely. This one did. And you'll see that in a second. And I sub O was defined as the current on the top, right there. And the question, oh good, I like this one. Determine the power absorbed by the 10 ohm resistor. And if you remember, just refresh your memory, power is voltage times current. And voltage I times R. So if you go I times R times I, you're going to have what? I squared times R. So if you know what I sub O, you are done. So the power really absorbed by the 10 ohm resistor, it's I-O squared times the 10 ohm, which is 10. So if you know what I sub O is, you're done. We're going to assign current any direction that you want. So here we go. Since I sub O is going to the right, I'm going to assign current this way. And this will be I sub O. It's the same direction. Notice? Right there. I sub 1. I sub 2. And notice when you assign current this way, that current has to be what? 6 amps. That current has to equal to this. So there goes one equation immediately. This one didn't go, but it gives me an equation. That didn't go, but so this is 6 amps. So right now, how many unknowns do I still have?
So I sub 3 would be 6 amps, basically?
If you want to do I sub 3, yes. If you want to call it I sub 3 here, that's 6 amps. Yes. It has to equal to that. So there goes one unknown. That means one equation is gone. Instead of 4 equations by 4 unknowns, now you're dealing with 3 equations by 3 unknowns. I said this one did not really get rid of one of the unknowns, but it gave me an equation. Notice the 5 was going to the right. The 5 is equal to what? What is the current to the right? I sub 2 minus I sub O. So that's another equation. So if you want to add I sub 1 to it, you can say 0 I sub 1 plus I sub 2 minus I sub O is equal to 5. The reason, again, I put the 0 so I can push the button on my calculator. 3 equations by 3 unknowns. So that's what this one gives me. But it didn't get rid of one of the variables. That did, actually. Again, I need 2 more equations. I can do this one. I'll make this yellow. So if we do that equation, KVL right here, we have what? Negative 4 plus 3 times. What is the current to the right? I need it to the right.
I sub 3, I sub 1 minus I sub 0.
So that would be, what is it? I sub
Yep.
1 minus what?
I sub 0.
I sub O. Yep. Minus this voltage here, which is what? 3 I sub O equals 0. Clean that. We have 3 I sub 1. There is no I sub 2, right? 0 I sub 2. And what about I sub O? Is that negative 6 of them? Negative 3, negative 3 equals 4. That's my second equation.
Could you say 3 I sub O is equal to I sub 1 minus 5?
3 I sub O.
He's using his the
Just out
graphic
of
calculator.
curiosity.
3 I sub O equals I sub 1.
Minus 5.
I sub O equals I sub 2 minus 5. You can use substitution. You can do it right here too, yes. I'm just taking the easy route, setting them up for my calculator. But you could, yeah, solve by substitution. Now notice I can't take this one as a loop. Let me remind you again, why?
We already know it equals 6.
Well, we don't know what the voltage here, right? So that's a current source. You could never do a mesh analysis right here. You don't know the voltage. You can't do this either. You don't know what the voltage here is. You can't do this one either. You don't know what the voltage here. So the only way to travel now, the only left one we did not use, is to go this way.
Wait, why couldn't we do the bottom right part?
Because we don't know the voltage.
You don't know what the voltage right here. You can't do this either. You don't know the voltage here. Can't do the top one. You don't know the voltage here. So the only way to go is right there. So if I do KVL that way, there's no voltage sources. So I'm traveling up to that direction. So I'm going plus to minus. I'm traveling, that's plus to minus. Coming down, that's plus to minus. So I need that current, I need this current, I need this current. So let's see. Negative 4 plus 10 times the current. What's the current through that one?
10 I sub O.
I sub O. Keep going. down here, plus to minus 4 times. What is the current from right to left? I sub O minus 6, yes. Plus, keep going, down here now, 5 times. What's the current coming down?
5 sub 2 minus 6.
I sub 2 minus 6. Continue traveling all the way to the beginning. That's equal to 0. So I don't see any I sub 1, right? That's a 0 I sub 1. Let's see I sub 2. I see a 5 of them. I sub O.
14.
14 I sub O. Now let's look at that number. This is negative 24 and that's negative 30, right? Negative 24 and negative 4, negative 28. And negative 30, is that negative 58? When you move it to the right side, that's plus 58. It might be worth it to redo it in 2 steps, but I'm stubborn. I already started that one. Distribute that, collect like terms. Hopefully I didn't screw things up. Negative 24 minus the 4, negative 28. Another minus 30 here. When you multiply that, that's 58. There's my 3 equations by 3 unknowns. I go to my calculator again. There we go, a new one. And let's 3 by 3. And let me put the values. 0, 1, negative 1, 5. Next one. 3, 0, negative 6, 4. Next one. 0, 5, 14, I hit the wrong key, hopefully it didn't affect anything, and 58. And solve it. So I got I sub 1 is equal to 274 over 57. I sub 2 equals 128 over 19, whatever, I can ask for approximation, and I sub O equals 33 over 19. So what is the average power absorbed by the 10 ohm resistor? Plus means it was taken. 33 over 19 squared times 10. So 33 divided by 19, that's 1.73 approximately. You square that one, times the 10, you have 30.16 watts. I love this calculator. This number will take 2 more pages of work for me to finish it. Once you find your equations, you plug them in.
Actually, doesn't look too bad, honestly.
It is easier than actually nodal analysis because you're not dividing.
Yeah.
So your equation a little bit cleaner, easier to solve mathematically. That's what I mean by easier, mathematically, you know?
Because the I sub O is equal to I sub 2 is minus 5.
Yep, all these simple equations, like this one is 6, this one is going to be I sub 2 minus I sub O.
And that would eliminate
Yeah.
the bottom equation.
Yep.
Since that would also only go to.
Yeah, you
I
could have
sub-
did substitution, sure.
And then once you find I sub O, then you can do the middle one.
Let's try one that looks like different look to it. We have time. Another example. Because we didn't do anything that looks like a diamond shape, so I'll throw one in. Plus to minus 3 volts here. And that's 1 ohm. And now we have a dependent source here. That's 4. Oh, my mistake here. That's actually not a resistor. That's a voltage source of 5, minus on the top, plus on the bottom. I'll fix it. I'm just taking the problem from the book there. Minus to plus, different book. I try to mix books all the time. (1.8) times Vx, this one. And with that value, actually, this is 1, and Vx is labeled as plus to minus right here. They're labeled plus, minus Vx. This is 2 here. That's my circuit. Now, for those people who don't like the way that one looks, if that like little diamond bending bothers you, you can actually take that circuit, take about a minute and redraw that. It will look like this. That's exactly the same circuit. It looks different. There's nothing between this and this. There's just a wire. That means these two are connected together. Between this and this, there's nothing, just a wire. That means these two are connected together. I'm sure you probably prefer to look at it this way than that way. Most people. So if that bothers you, that look, then change it to this. Let's assign current again. I sub 1, I sub 2, I sub 3. And I got Vx already. If you look at Vx, if we just look at it, can you write Vx in terms of either one?
I sub 3.
Vx equals Ohm's law, 1 times I sub 3, which is I sub 3, yes. So every time you see Vx, write now 1 I sub 3 in place of it. Otherwise, you're going to have 4 unknowns. I sub 1, I sub 2, I sub 3, and Vx. 4 equations by 4 unknowns. If you're using a calculator like mine, who cares if it's 4 unknowns or 10 unknowns? So now I'll do KVL right here. That's right here. So I'm going to be traveling this way. I'm going to mark this plus, minus. I need that current. Plus, minus. I need this current. I'm going clockwise. Plus, minus. I need that current. What's that? -3? Plus 1 times the current to the right. What's that current to the right? I sub 1? Right? Plus to minus. What's the current down here?
I1 minus I2.
I1 minus I sub 2. What's the current down?
I1 minus I3.
How about I3? Right? I1 minus I3? Yep. I don't know if he said 2 or 3. I wasn't sure. Okay. Let's collect like terms and see. 1 and 4 is 5. 5 and 2, that's 7 I sub 1. Negative 4 I sub 2. Negative 2 I sub 3 equals 3. I can't take this and do KVL here. I keep saying that. Why? What's the voltage right here? That's a current source, not a voltage source. Some of you are going to make that mistake on the test. They're going to do it, and they're going to put here 1.8 Vx. That's a current source. You don't know the voltage here. So I can't do one here. I can't do one here either. I don't know the voltage. I could go on the outside of that. I could go this way. So if I travel on the outside, I'm going to have what? -3, another KVL, plus 1 times I sub 1, continue. That's a -5. I'm traveling, I'm going clockwise, so this will be what? Plus to minus, coming down, that's Vx, plus 1 I sub 3, that's what Vx is equal to, equals to 0. So if you travel on the outside, this is what you have. Clean it. 1 I sub 1, there is no I sub 2, 0 I sub 2, plus I sub 3, or 1 I sub 3, is equal to 8. Second equation. I need one more.
The outside of the right two?
The outside, like this.
Yes.
The problem with that, if we use them, since I use them here, in the first equation, I use these two, and I use these guys on the outside. If you take this, I already used them. You're going to find the math is not going to work. Because for the inside one, notice, you try to use something you didn't use. When I did the inside, I went like this, the first one, the first equation. So I used this and this. When I went on the outside, I used this and this. I used them. So if you do the outside, that's a loop, that's fine. But I already used this and this in the second equation, use these two in the first equation. So you're going to see it's going to be like a silly answer. You're not going to have an answer mathematically because you use those equations or those spots. You already used them. So I got to look for another option. You can try that. You'll see the math just cancels out. You end up with like, hey, what happened here?
Since it's a current source, isn't it 1.8 I sub 3?
So that current source, I can use that. That's 1.8 Vx. Vx is what? 1 I sub 3. That's the current going to the left from right to left. That should equal to what?
Minus I sub 3.
How about I sub 2 minus I sub 3? I sub 2 is pushing current in that direction. I sub 3 is pushing current backward. The difference between this and that should equal to this. That's your third equation. Clean it. 0 I sub 1 plus 1 I sub 2. Is that negative? Is it 2.8 I sub 3? Oh no. Plus.
No, it's minus.
Minus. Okay, I'm gonna put 0. Okay. You moving everything to that side? Okay. I was about to make this one minus, that's a plus, the same thing. Move them to this side. Won't make any difference. So that's your third equation. Here's my calculator here. Three equations by three unknowns. Okay. I have 7, negative 4, negative 2, 3. Next one, 1, 0, 1, 8. Next one, 0, 1, negative 2.8, and 0. And I got I sub 1 to be 5.376, I sub 2 to be 7.347, and I sub 3 to be 2.624. Again, if I push all the right buttons, that should be my answer. I was about to stop the video and start doing something else, but there's only 10 minutes left, 15 minutes to start the new topic. I won't start the video. I'll just give another example on it. Oh, you know what? I'll start the video. I won't call it anything, but let me look for one, because I want you to think about this for a second. Try and find a good example here. Here's an example. That looks like a simple one. Let's say there's a 10 ohm here. We have 5 amps. We have 1 ohm. Five. This is 4. And this is 17. Let's say the question was, I'll make something up. I'm going to label this Vx, find Vx. Now I left the question like this. Just find Vx. I didn't tell you what method to use. Now, so far, because I'm laying the foundation for the next topic for us, so far we know nodal analysis and we know mesh analysis. If we think about nodal analysis, if we make this is the ground here, we know what the voltage on the top is. What's the voltage on the top? 5. So that's not unknown, right? There's a node. Do we know what the voltage here is for that node? No, that's 1. There's a node here. Do we know what that voltage for the node? No, that's 2. There's a node here. Do we know what that voltage there? No, that's 3. So if you were to solve this problem with nodal analysis, how many equations by how many unknowns are you going to have? 3. 3 equations by 3 unknowns. Node 1, node 2, node 3. If we do mesh analysis, this is I sub 1, this is I sub 2, this is I sub 3. In this case, how many equations by how many unknowns are you going to have? 3. 3 by 3. So if I use nodal analysis, it's 3 by 3. If I do mesh analysis, it's 3 by 3. So the number of equations don't change. But which equations are easier to deal with? The mesh or the nodal? So I'll go with mesh analysis. You will see actually that the next topic I want to set the video on is looking at a problem, deciding which method is better. In some cases, you might have, for example, if you have a lot of voltage sources, I can guarantee you nodal analysis will be much better because you know a lot of the unknowns. If you have a lot of current sources, mesh analysis is better. In this case, they're really the same thing. Both will give me, when I say the same, they both give me 3 by 3. 3 equations by 3 unknowns. But since mesh is easier to do, I'll do it with mesh analysis, and this way I don't have to change my video. Next class, you'll see me give you different examples where nodal might be easier or mesh might be easier. So with this, I'll go with mesh analysis. Again.
Start with the current, I guess.
Now again, I can't take this loop. You want to start with the current? The 5 amp is equal to what? That's the current up.
I sub 3 minus I sub 1.
Perfect. That's my first equation. Negative I sub 1, write them nicely. Plus 0 I sub 2 plus 1 I sub 3, or just I sub 3, is equal to 5. That's one equation. So quick and easy to get that answer to it.
Vx is equal to I sub 2.
Vx,
No, it's not.
Vx actually is defined plus to minus this way. So it's going to be 1 times the current going to the right. What is the current going to the right, from left to right? What's that current? I sub 3 minus I sub 2. So if you want Vx, that's I sub 3 minus I sub 2. Okay, in case I need it. But I need to write a couple more equations. Outside, I heard someone say outside loop. Okay. That's this loop right here. If you follow that, that's negative 5 plus 5 times, I'm traveling clockwise, what's the current down? The current down, the current in this direction. I'm going that way. So 5 times what? I sub 2 plus 4 times I sub 3 plus 17 times what? I sub 3 is equal to 0. I don't see any I sub 1. 0 I sub 1 plus 5 I sub 2 plus, is that 21? I sub 3 is equal to 5 again.
Then it doesn't matter which one we choose, whether it's the top right one or the,
You have to use the top right one. There's no other choices.
instead of just doing it like a box.
Oh,
Instead of just doing
oh, you mean this way?
Yeah.
You can do that. Yep, that doesn't matter. So the option really is either to go this way if you want to, or you can take that one. Notice I didn't use this or this in either one. So if I take it this way, I'm fine. And if I do that, I'm fine. I'm using both of these. I'll just be different. I'll go this way, just because it kind of looks cool. Traveling this way. -5 plus 10 times, I need to know what the current down is. I sub 1 minus I sub 2. Plus Vx, right? Because you're going this way. Plus Vx. What's Vx equal to? 1 times I sub 3 minus I sub 2. Yep. Continue.
That's plus 17 I sub 3.
What about the 4?
Oh, sorry.
4 I sub 3, right? Plus 17 I sub 3. Again, I could have took the easy way out and did the top one, smaller one. That'll be fine too. But that looks nicer this way. It looks intense. So what do we have? 10 I sub 1? -10, -11. Let's see I sub 3. I got a 1 here and a 4, that's a 5. 5 and 17 is 22, is it? Equals 5. Three equations by 3 unknowns. There we go. Ah. So I have -1, 0, 1, 5, 0, 5, 21, 5, 10, -11, 22, 5. Solve. I sub 1 equals 153 over 40. I sub 2 is equal -1, and I sub 3 equals 3 over 8, which is I think 0.375, 3 over 8. I think it is. So what is 153? Oh, get out of this. I should put my calculator in approximation mode, make my life easy. 153 divided by 40. $3.825. Maybe I'll do that.
You can hit the
Green.
button,
Yeah.
and then you hit the enter button.
The only problem is you have to do it for each one, I think. I don't know if you can get them for all.
And then you can go into the,
Let's see if it'll do that. Actually, I never did that. Let me see if it does that.
if you go to mode,
And change it to approximation.
you can change it to.
Yep. Because I use it for other class as exact. So here we go. When I get here, if I do the green, enter. See, we'll only do one at a time.
Yeah, so then we can go
Yep.
into mode.
So I have to go to mode and change the mode instead of exact. I know there's one that says I can't see. till I zoom, it's approximation on the right. Is that exact? Nope.
Keep going. Keep going.
That's exact.
That's the one you want to change.
So error to the right, and should give me approximation.
Number 3.
3, enter, and that'll make it. But for my next class, I gotta change it back to exact. You know? So in some case, I need exact, so I was just lazy to do it. So now if I go back and I do the equation current, now it gives me the answers instead of being inexact. Now it's approximation. Well, this actually in this case is exact, happens to be exact, but you get the numbers now all the time. Okay, we'll stop here. Next time we'll do comparing. Like you have to decide when you're doing a homework which one is easier for me. Again, with the calculators, really not much of a difference, but you know the math in Mesh is a little bit easier than the math in Nodal Analysis. We're going to do them the right way. We're going to look at it and see that's 2 by 2, that's easier than 3 by 3, or less equation. Let's do them that way.